Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing linear inequalities. This is standard A.2H in the great state of Texas, and we are using item number 14 of the 2025 release STAAR test. If you haven't done so, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it. We will look at our answers together. We have a verbal description here. And we need to turn this into an inequality. Look at our four answer choices here. So let's take a look at what's happening here. A baker wants to order apples and blueberries. And so we've got apples at $2.50 per pound. So I'm going to change colors here. I'm going to do my apples in red and my blueberries in blue. That makes a little bit more sense. All right, so the apples cost $2.50 per pound. And the blueberries cost $3 per pound. The baker does not want to spend more than $75, so let's just put that as our maximum here. Now, which inequality best represents all possible combinations of x? So they've defined x for us, the number of pounds of apples, and then y, the number of the pounds of blueberries that the baker can order. All right, so we are going to use the 5.5, or sorry, the 2.5 and the 3. And I'm not sure where this 5.5 came from, so we can go ahead and just get rid of this. It doesn't make any sense because we're dealing with apples, we're dealing with blueberries. All right, so let's look at our colors here. Apples are $2.50 per pound. Apples are going to be represented by X. Okay, so we're going to say apples are going to be $2.50 per pound. And then we're going to say the number of pounds is X, 250X, and X equals number of pounds of apples. Now, what do we know about our blueberries? All right, so blueberries are a little bit more expensive. They're $3 per pound. So that's our unit right there. And they're going to be Y. We can't have the same variable be pounds of apples and pounds of blueberries. And since we want to differentiate those 2 pounds, we are going to need 2 different variables. So let's make this Y right here. And we'll just go ahead and define this down here. Number of pounds of blueberries. All right, so what are we going to do with those two values? The $2.50 per pound for the apples, $3 per pound for the blueberries. Well, if you're going to order them and pay them, you want to figure out how much they're going to cost. So you are going to need to add those. And we can go ahead and simplify them rather than, we don't need the dollar sign, we don't need the zeros. Okay, so we can simplify this here. We can say 2.5x, since we're just going to multiply, right? We know that it's dollars and cents, plus, and then we don't need the dot 00, we can just call it 3y. Now, what's the only other number we have? Well, he's got a budget, doesn't want to spend more than $75. Okay, so we've got this that we can kind of eliminate here, because look at this, it's got the 3 with the x. The 3 is the cost per pound for blueberries, but the x is the number of pounds of apples, so that doesn't go. And once again, I'm not sure where the 5.5 came from, unless you're just adding the 3 and the 2.5, but that doesn't make any sense. So we're left with B and D. The only thing we need to figure out is which inequality are we going to use. He does not want to spend more than, okay? So these two together need to be less than $75 because he doesn't want to spend more than that. He wants to have some back. Now, can he spend actually $75? It doesn't say that he can't. I think he would be good with spending up to $75, so we need to make it less than or equal to, because that's his maximum, and you can include that. So our answer here is going to be B.